Hi folks, 2019 short questions here. And A1 says the image shows a multi-story building in Chicago. The front structure is comprised of a series of glass panels. The drawing shows the projections of three similar glass surfaces, ABC, BCD, and CDP. So for part A, determine the dihedral angle between the surfaces ABC and BCD. And you can, first thing you need to do is identify the line of intersection. Okay, so we have it there in the written form. Here it is down here. So when we're looking for a dihedral angle, we're going to look in, first of all, there at it perpendicularly to get the true length. And while we're at that, we'll bring 1 point from each view. Set up our x1, y1 line. And we're getting the height from two views back, which is our elevation. Now, we have the true length, so the second thing we're going to do there is we're going to look along it. Rule of geometry, if you want to see a planes and edge view, you have to have a true length line and look along it. And because this line is common to both, we'll be able to see both of them as edge views, both planes, if we bring a point then as well from each plane. Next to y2. So new view, one view back, two views back. So A there straight away is there. B and C, and you always know you're measuring off the right line when the XY is parallel to BC, because that means B and C have the same distance to the XY line, which means to be seen as a point. They have to be seen as a point then. If you measure from anywhere else, you would be looking at a line, not a point. And then D, the last one. And that, folks, is your dihedral angle there. Part B now says, draw the elevation and plane of a horizontal line on the surface CDP, which will pass through P, and determine and indicate in degrees the inclination of this line to the vertical plane. So we'll take it across here, level line, drop it down now into plane. And that is the line recreated. Now we want to know its inclination to the vertical plane. So if you run that onto the XY line, and remember the XY line is an edge view of the vertical plane in plan view. Okay, so then you can throw down your set square there and measure it off. So I make it there at 26. And that is question A1 done, folks. Okay, so A2 shows this building in Dublin, and it's based on a hyperbola. And part A there is asking us to locate the vertex and 5 additional points on the curve and draw the top portion of the curve. So the first thing I would do there is, and similar to all conics, you can come up there at 45 degrees, where it hits the eccentricity line, drop down, and that'll get you the vertex. Now there's these ordinates kind of already set up for us, so we'll use these. And you can put an ordinate anywhere, it doesn't matter. So where it hits the eccentricity line, bring it out to hit the lattice rectum there. We'll get our compass after that. And what we're measuring off is this height here first, Now, but all the swinging will be done from the focal point. So you drop it down there and swing out. That'll get you a point. And keep dropping it down and swinging. Now, when you have your points there, we can do in our freehand curve. Part B then says, draw a circle which shall be tangential to the directrix and also tangential to the hyperbola at P. So if it's going to be tangential at P, we can set down our set square like so and say that the center of that circle must be on a line that is perpendicular there to the eccentricity line there. Okay. The other thing is, if it's touching both of them, the center of the circle must be on the bisector of the eccentricity line and the directrix. So get your compass there, bisect the angle. Now this is the place we'll put our compass to draw that sphere. And that is A2. Question A3. So we have what is an interpenetration question here. And so part A says, complete the elevation and plan showing all lines of interpenetration. So if we run them up, finish out the left hand side first. Now we finish out the left hand side. The right hand side then, drop down that guy, this guy. You can run them in then. Now the only thing that's missing here is, of course, it's going from one surface onto another. So there's 2 points of interest here we must locate. Now the handiest way I think of doing that, these points of interest are going to be on this point, okay, which is an edge view of that line there. And if we take a horizontal cut, I think it would the easiest way of finding this. So we can drop this line down to hit AC, this line down to hit BC. And when we run them back in, when they cross this line, will give us the point of interest that we're looking for here and here. So then we can go and we can join that up to there, up here like so, down and to there. We get your hidden detail line here, and we can finish in these lines there. And that's part A done. Part B, determine the true shape of the triangle ABC, where we're looking at a true length of AB. So I think the handiest thing to do there would be to run out a line like so. Get your compass, set it to B there. And we'll revolve that out. Same with C. Revolve that as well. Now we can bring up these lines and then bring them out. So this will give you B1 and C1 up here. And that there, folks, is the true shape that we've been asked for in part B. Hi folks, A4, and it says the drawing on the right shows the plan partially completed perspective drawing of the end portion of a GA pitch. The goalposts are also shown. The position of the two vanishing points are given in the perspective drawn. Part A, complete the perspective drawn of the given end portion of the pitch. Okay, so we kick off there. They've partially done for us. You have this point going here, so this guy can run back to VP1 there straight away. You can extend on this line coming out here for that side of the pitch, and then if you want to get that point there or any point you want, join the spectator or across the picture plane, drop down there 90 degrees. That'll get you that point there. Then we can put it down on VP1, run a line back this way. We can do them lines in heavy then. This point here as well, we'll get it. That's where it ends. Use that guy heavy. And we want these two lines now, okay? So take that point there, join spectator, drop them down, and do the same as the other point. And that's part A done there. Part B then says to us, determine and show the true height of the goalpost upright. So what we'll do is we're going to take a shoulder line, slide it out to there. It's hitting on this point, which is going to bring it straight down along this line. So somewhere along that line now will be the height of the goalpost. Now the goalposts are themselves dots, okay, represented in plan view. But what we want to do is, you have to pretend that if we were going to shove that goalpost straight up, so to hit the ground line, so we'd be looking at the true height of it, okay. And if you're doing that, it'd have to go straight out here. Now these lines, or when this guy even comes out here, and this one is parallel to this line, which helped us set up VP2, okay? So you already have the goalpost there. So if you get your pencil and you extend it on through, it's like you're shoving that forward up until it hits the picture, this two goalposts until they hit the picture plane there, which will give you the height. So that there, from here to there, will be the height, true height of the goalpost. And that's those questions finished, folks. I hope you found them useful. Take care. More videos to come soon.